So in this video, I'm going to outline chapter 1 in the yellow packet that I gave you for our AP review. What I expect that you do as you watch the video, you fill out your outline and you bring it to class with you because we're going to be working on these questions next week. So example from chapter 1 is exploring data. We looked at categorical variables. That's just a category or group that an individual belongs to. Eye color, hair color, gender, grade, social class. They have different categories. Quantitative variables take on numeric values. They have units, grade point average, ACT score, income, age. If I want to make something that's quantitative categorical, I could say age is like youthful, middle age, older age, or put categories like 10 to 19, 20 to 29, 30 to 39. We talked about shape here. 4 different kinds of shapes. Skewed to the left, the tail is on the left. Skewed to the right, the tail is on the right. Roughly symmetric. Bimodal, 2 peaks. Measures of center, we talked about mean and median. Measures of variability or spread, we talked about standard deviation, IQR, and range. Range is max minus min. I'm going to try to highlight a few formulas. This is not on your formula sheet. This is one I would know. I doubt you'll have to know the range, but that's one of about 7. Resistant means that they don't change much in the presence of skewness or outliers. The median and the IQR are resistant. The mean and the standard deviation are not resistant. So we pair these together. If we're describing a symmetric distribution, we want to use the mean and the standard deviation as our measure of center and variability. If we're talking about a skewed distribution, we want to use the median and IQR as the measure of center and variability. If the distribution is skewed left, the mean is less than the median. If the distribution is skewed right, the mean is greater than the median. Why? The outliers and skewness are either going to pull the mean down or pull the mean up if the distribution is skewed to the right. If we're talking about a box plot, 5-number summary is going to be your minimum, first quartile, median, third quartile, and max. How do you test for outliers if you have a box plot or you're constructing a graphical display or just checking? Here are 2 more formulas I'd add to the list that are not on your formula sheet. The IQR is the third quartile minus the first. And then here's your formula for outliers. If you have any number less than quartile 1 minus 1.5 times the IQR, or any number greater than quartile 3 plus 1.5 times the IQR. Okay, on to the second page. So how do you make these graphical displays? So if we're doing, say, any kind of graphical display, I'm going to take the raw data and put it into a list, and I'm going to calculate one variable statistics on that list so that I can get the standard deviation, I can get the mean, median, I can get the range, IQR, I could calculate if there's outliers, and then I'm going to describe the distribution using VSCO, variability, shape, center, outliers. I could use the calculator to make a histogram box plot, or I could just make a dot plot by hand or a stem plot. Then we talked about marginal and conditional distributions. So marginal is totals. So if I want the marginal distribution of classes, I'm just looking at the total amount of students who took each class. It could be counts, or if I see the word relative, that means percentage. So just converting these to percents. Conditional distribution is based on a specific row or column. We, in this example, are only concerned with students in AP Bio. So I'm only looking at the specific column. So I have people who are juniors or seniors in AP Bio. And this is conditional probability, which we learned later on in the course. One thing that I did not teach that was part of the AP curriculum earlier in the year, I just didn't know if we would have time, that I'm going to go over now, it's nothing really epic, is what's called a mosaic plot. We did side-by-side bar graphs. We did segmented bar graphs. All this is a segmented bar graph where the width is proportional to the overall total. So here, 1,221 out of 1,526, I don't know what that is. Let's call it about 80%, I think, of the respondents were a no, and the remaining 20% were a yes. So the mosaic plot, this is about 4 times, you can't even see what I'm doing. The mosaic plot, this is about 4 times the width of this one. That represents the 1221 out of the 1526, that percent versus the 305 out of that. That's all. So it's just a modified segmented bar graph. That's all. So they give you another two-way table here. What I would do, I would pause the video and answer part C, just doing the best you can to use the mosaic plot to talk about the association. So here, there is an association. These are not exactly the same. I'm not even caring about the width, to be honest. And I could see the biggest discrepancy is in the underweight. So there is an association between these two categorical variables, gender and body image. Males are much more likely to identify as underweight than females. Looks like maybe about 3 or 4 times as likely. I could get percentages to strengthen that argument. And just so you could see, there were 760 females out of 1,200. That's 63%. So 37% males. So that's how they determine the width. This is about 63%, 37%. And it's arbitrary. It's not like we're scaling this off as like 10, 20, 30, 40, 50, 60. So nothing really groundbreaking. All right, that's a quick overview for chapter 1. You should have taken notes on this and have this outline filled out ready to go.